basically to check our size of turbine that is suitable that we can build. Okay. So this is basically the summary of this project. Firstly, to extract energy from those two currents, and also for the electrification of the remote area. Then we want to also to come up with some sort of a novel concept of turbine, developed based on our proposal with supported by the government. And then we have this our Malaysian plan. This is one part of our national plan. And in Malaysia, we have this ocean energy can be a resource for green marine renewable energy, because Malaysia is well covered by the ocean. We have a very long coastline. So naturally, we want to utilize this marine renewable energy. Marine current turbine has already been successfully implemented. So it seems that these are now proven concept. Only we need to apply it to in our own area. Okay. So when we say rural area, first thing we have to know how much energy that is demanded from rural area. So this is the basic requirement nowadays. We need sort of land, laptop, desktop, the like, basic electrical requirement for the rural area. We come up with some figure of say 4,450 watt for that one particular household. So we said, okay, let's have a design bit. Okay, so before we start to design or build the turbine, the MATLAB simulating program. So the MATLAB simulating program is like a virtual device, renewable energy device. So from there we can put as though a virtual turbine there, a virtual generator, because using the permanent. This is the pulley type to change the torque to velocity, and then we have this. So this is basically the schematic of the program Simulink. Okay, right? So when we use the Simulink, we figure out that we need a turbine that can operate in 1 meter per second. And here's an arm. This is the rotational speed of the turbine. Okay. And then there is some value of the torque, and this is the power that can be generated. And this is the amount that we figure out that we can generate per day energy, which corresponds to the requirement of this one household. Okay. So then we start to design the turbine. One turbine, since it needs to be floated near the surface, so it has to have a buoy. And inside the buoy, you have some the pulley system and the generator inside there. So its function is just to float the turbine. Also has space to put the generator and the pulley. So basically, this is the shape of the turbine. And we have an extra bit here, which we didn't really implement. It is just to improve the flow of the blade. The turbine blade only works half of the part, half of the turbine works, The other half is actually going against the speed of the current. Okay? So we need to to block this one so that we can reduce the drag. So to divert the flow from this side to the other side. So that logically improves the performance of the turbine. So, okay, the size is about that's given here, about 1 meter high, 1 meter high, radius about 0.6. draft is expected about half meter, freeboard. It's made of fiberglass, also stainless steel, the mechanical part. And all together is about half a ton. So the idea here is so that it can be carried by about 4 persons. So because it's a rural area, you must be able to transport it by the human being. So the size has to be right as well. This is the thing, and you have to have enough energy to be retrieved, from the environment. Okay. So this is just showing you the mechanism that how you get the energy. So we have the plate here, and also we call it the deflector. So we can deflect the flow from here to this side, so that we can improve the torque of the turbine. And also because the current speed is the tidal speed going back and forth, so we put a rudder so that it always point towards the current, coming current. But this is maybe not, it's not practical, Maybe you have to think of something else. This is the actual building of the construction of the turbine. This is to show that how big it is compared to one person. But the boy. Okay. And then what we did now is that we need to check the especially the power coefficient. So that means we have to know how much torque it can produce at what speed. So we put it in our towing tank. So fortunately we have a long towing tank, 120 meter long, 4 meter wide, 2.5 meter of the depth. So what we do, we put this turbine model scale, and then we can tow it in the towing tank to simulate the current flow. So as we tow it, the turbine will start to turn. So these are some of the features that we have to incorporate to get the parameters that we want. So we have sort of pulley, have the wire, and then we put into some loading. Because this turbine, look, once they look, so we have the load against the speed of the turbine. Then this load will vary. Higher load you want, higher load you want to generate, the more torque on the turbine you have to have. Okay, so this system is just to capture the load and also the speed of the turbine. So this is the plot of the power coefficient against the tip speed ratio. So as you can see, as you increase, then you have change in the tip speed ratio. But if you start to increase at a certain point, the turbine will not move. So this is the area where the turbine actually doesn't move. The top high. Okay, so this is the top position. So torque and power is about. So torque is just always the torque times the rotational. Okay. Next. Same, is it? Very small. Okay. So from the experiment and simulation, we come up with this figure. So let me think, okay, we can still achieve it after doing some. You can validate the simulation result. So we figure out yes, you can still achieve some power output that we require. Okay. So the next thing, once we have the construction, we have to put it actually on the site. So this is a site near at the tip end of Johor. Yeah. So this is the most southern tip of the Asian continent. Just put it here. So this is an area where there is some fishing activity, where you have the fish farm. So the problem with this fish farm, they cannot get the main grid. So they basically have to use this generator to get electricity. Okay. So this is you have to have a lorry to pick this up and you have to transport it on site. So you see that the size and weight of the turbine have to be considered. Because there's not much facility that you can live on. Just from the lorry, pick it down, and after that, you have to use the wind power to transfer it. Okay, next one. Next slide. Yes, so we have to have a sort of a platform, a floater, so that we can put the turbine on the floater and transport it to the fish farm. This how so this is now the turbine on site, floater platform, and then by the fish farm. And also we have the device to lower and lift the turbine up. We have some constructed. Okay. So these are my PhD student from India. This is my colleague, electrical engineer, electrical lecturer. He owns the farm. Okay. I was lucky to have that, to know him. So this is the rack where we put the so this is the battery. So we have two sets of battery. One for charging, the other one is charging. We have 8 batteries. Okay, and we have also a charge controller. So this is our surprise when operating the turbine. Just a few days, found that there's a lot of barnacles and corrosion. That was a big setback for us. So what we do, but the next one is we make another turbine. Fortunately, we have some money left to make a turbine made of composite. So now we change the material to composite. Okay. This is the composite buoy of it's the same shape, just made of composite. Okay, next. So now we can try, we can use this composite one, but still we have problem with barnacles. Barnacles still there. So we need maybe to have special coating to avoid the barnacles. Okay, next. Okay, this is the complete construction of the buoy. No metal parts, all are composite. Okay, next. So we again to get the data. Okay. This is again the same process that we have to do. The next one. So this is the result we get. So this is the result showing the current speed and direction. So this shows that the direction change. The direction change. And also the current speed also change to the direction. Recorded for 24 hours. Right. Okay. So this is just the showing you the same result, showing the different current speed. So showing you that it's not constant speed, depends on the tidal current. Okay. So this is showing you the top. So the top is the you have higher speed, you have higher torque. Okay, so this is the power you can get. So you notice that the power is not that constant, so it depends on the current speed. You see there's a lot of energy that you cannot capture, you know? Only this part and after the end. Okay, again, the power and the army the current speed was very low, about not even 1 meter per second, about 0.6 meter per second. You expect at least 1 meter and above. We didn't get that. So we thought, okay, let's modify it using solar panel, add some solar panel system. Okay. Next one. So this is the again we go with the simulating. So simulating program are quite handy. So we just add in the solar, estimate the power that can be derived from the solar, add it to the power from the turbine. Okay. So I have a master student that study this. So we got one solar panel and then we test the power that we can get based on the sunlight, because it depends very strongly on the sunlight. And also another problem we had is I don't think we can go back to the same activity. Civil engineers software to estimate the current speed around some location. So we know there's a location in near Kuala Lumpur, is a Klang area. So there was they say that this is the area got a better current speed. So we just simulate the current speed with this software, the 3D. Got some friends from the civil engineers to help us. So that means as a number architect now I can say, oh, the civil engineers, good to have friends from the civil engineering discipline as well. Okay, so the next one. So this is what the velocity that we get from that area. So basically we got a higher velocity of 1.48 meter per second, the lowest about 15. So the average about 0.5, much better than the one that was, but not as good as we expected. Next. So this is to show you the power that you can generate using the solar panel as well as using the vertical axis current turbine. So you can see that this is the average solar panel. It happened only between say 8 or 9 o'clock until about 4 o'clock. After that, just almost zero. And this is the green one is from the turbine. Sorry. Okay, the blue one is from the turbine. So it depends on the current speed and the tidal. So it goes up and down. So we got two peaks during the about 8 o'clock, and there's another peak near midnight. So if you have to combine this, you tend to have a better capture of the energy, hybriding the current turbine. In a 15-day cycle, so every 15 days, they do this cycle, because the tide changes in the month, twice a month. So that's the thing that we can propose, that if you were to use this vertical axis current turbine, you need to hybrid it with three solar panels. Okay, now we can start to think, why not just use solar panel? Okay, okay. Now we can see how you want to promote it. This vertical axis current turbine. Okay, if you use solar panel, you have to have more solar panel, right? Okay, then that means you're covering a much bigger area if you just use solar panel. But if you hybrid it with the current turbine, then you have lesser solar panel that the surface area that you use the solar panel, then you have a better flexibility in installing the solar panel. But the solar panel is in the area of, say, sometimes it's been used for navigation. You cannot use the whole area. You can only okay, so that's basically that's the conclusion of this project. You can say that yeah, you can use the turbine, you can get some rotate and depend. Maybe Indonesia can do it. You have many times our population. Can do the mass production of this system. Okay, thank you very much for that. Any questions?
Langsung aja ya Pak ya. Ya, jadi siapa aja mau nanya ya? Ini karena terbatas sama 3 orang aja.
In English or Indonesia? Okay, my name is Farman. I'm from Master Degree Mechanical Engineering in ITB. This topic very interesting for me, and I have a question about efficiency for this kind model because I found in several sources about minimum capacity for cutting 1.5 meter per second. But in your presentation, it's not below time limit. So the question, how the first question, and the second one is how to explain to the impact itu materi is thank you.
This is a region of low speed cut. That's why your production will increase the torque. If the turbine can turn, the generator we have energy.
But I'm not sure about how much energy we can generate. Energy.
The question of can you still the energy? Solar panel produce direct current DC. Although the magnetic solar panel connected to DC. So you have to just inverter and do the transformer. Your velocity
As far as I know, when we generate energy, we have limited speed to generate. So if we produce energy, as far as I learned about generator,
standard, what do you mean by standard?
velocity.
Yeah. Again,
Generator.
for the experiment, we notice how low can the speed of the current be to turn the generator. But you can look at the experiment. We have the
Okay.
the load.
Yeah.
You put the load, and we know that but when the speed is so slow, you won't be able to turn the generator. So that is the minimum speed. I think above 0.5 meter per second is still.
Thank you. That's all. Sorry.
Another one part of another part of the question. I think one part is the solar, yeah. So this is the hybrid solar. That means the hybrid, the advantage is that you don't need the energy from. But the solar panel, very cheap. But it depends on if the government gives support. It's very expensive. So perhaps the government can support it. Especially Malaysia, I don't know for sure. People are very comfortable. But they get so good. Oil is very cheap. But we have to think for the future, especially for younger generation like you. In future, we never know. If there's no more oil and gas finish, or the air becomes so polluted, you cannot use oil and gas anymore.
My name is Ramadana. I'm sorry, I'm today the juga. Oh ya. Jadi saya ingin bertanya, kalau untuk desain low speed turn turbine ini, adakah faktor-faktor yang membedakan dengan mendesain turbin yang biasanya? Menurut saya kayak turbinnya, diameternya, atau mungkin komposisinya. Terus yang terakhir, mengapa memilih desain tersebut? Karena saya pernah membaca kalau di desain vertical axis itu yang paling efisien itu adalah bentuk gorlock turbin. Terima kasih.
If I may translate, he wants to know what kind of factors that can determine the design of the turbine design, that what kind of aspects that affect the design of the turbine, and why was that kind of design was selected instead of other types, because as far as you know, there is a better type which is Gorlock turbine. Gorlock turbine. Okay, so maybe that's the question.
Because mentioned this in the particular SCR, there's generally two types, you know. One is the direct type. Direct type means turbine. Our area is even the area is turbine work very well. So we have to use the direct type. And then with the direct type, we have to give an the step in it. I mean, the turbine. Yeah. If the current speed is high, close to meet, better use the propeller.
So she still wants to know about what kind of factors that. So what kind of factors that makes this design to be distinguished, to be different with the other design, like maybe the benefit that it gives, but what's the difference, the main difference between this turbine and the other?
Very low speed current. So you have first to consider the increase the torque. Higher torque means higher power. Okay. Also, you have to reduce the drag. See, the turbine only works half side, you know. One side is giving the thrust, but the other side is giving the. So the thing is increase the torque on one side, decrease the other drag on the other. Is first to make it the angle more less less drag. The plate that one of my, we try to get in that by using arm. So one arm open the other side and the other arm closed. That's one way. The other way is my PhD student still doing using the deflector. So the deflector is the two what I call function. First, it blocks the water on the side of the turbine. It blocks, so you reduce the drag. But the drag is also higher speed against the flow. You have higher drag. So you block it, and then as well you divert the flow towards the other side of the turbine. So you can increase the thrust. So that's the way we try to do it.
For the answer, maybe this is the end of this session because we have a limited time and we still have two remaining speakers left. So thank you, Professor Adi, for your time. Please. Okay, so the next one is Dr. Fitri. Dr. Fitri ini dari University Malaysia Terengganu. Beliau expertise beliau ini di computational fluid dynamics, dan mungkin Dr. Fitri akan deliver this in bahasa or English. That can be both. Actually, sebenarnya Dr. Fitri ini orang Majalengka ya, jadi lebih fasih dalam bahasa. But still, kalau mau ngomong pakai bahasa Inggris, no. Okay.
Assalamualaikum warahmatullahi wabarakatuh and very good morning. So thank you very much to Dr. Jessica, giving a time to, not present or maybe not also giving the lecturing, but a bit sharing with you. Because I do believe, here some professors from IPB and also lecturers like Prof. He actually is knowledgeable than me. And if you compare, I'm Earth and they are actually is sky. So if you find something that actually not, correct, just inform me that it shouldn't be a problem. Okay, so actually, my expertise as seen like Prof. Adi Maimun, I'm also background is the naval architecture, and just recently, I'm trying also to apply to the coastal protection, your floating big waters. So normally the big waters is constructed with the fixed big water, and maybe regarding to the cost, sometimes also it's a bit considerable, but I will not see from that perspective. So I would like to see that the fixed big water, something also giving some weaknesses. Has a side effect, and I would like to show you, the real cases that happen our nearby our campus, because our campus is very near to the South China Sea, so maybe only 30 meters from the sea. So, okay. Laptop, okay. So actually, this the conventional big waters, So many rubber mount big waters, and then and also we can see here that despite effectively dissipate wave energy, so the big waters are still vulnerable and suffer from the strong refraction. So this our problem that we would like to solve. Why we propose the floating big waters? Because the reflection actually giving the side effect. So our campus nearby to the airport and some big water constructed already, done there. But once we, constructed the fixed big water, so this, deviating the, some distraction nearby the fixed big water. And then the other thing, so also giving the, some high cost construction, because of course the need, for construction after this fixed water. And then we can see here waters. So the expansion and also the erosion slightly, happen here. So you can see that the, the other side of, actually happen in our nearby campus, University of Terengganu. So you can see here, the street here, actually eroded by the sea, sea wave. And yes, I told you in this area, Kuala Terengganu, so for about maybe almost 100 meters, from the original before we build up the, fixed breakwater, because we would like to, we have done, the extension of the airport in our area. Due to the construction of the airport, and we try to extend, the the landing way of the airport. So become, giving the side effect near, floating water. Why we propose floating water? Firstly, in terms of economy, we can reduce the cost, because I think about 2/3 of the web energy, the dominant of the web energy actually happens in the surface, about maybe 2/3 of the depth. So if we build up, the fixed breakwater, so actually we should extend until the seabed, and also this is very cold. And by the floating breakwaters, we need to protect at the dominant area of the web energy. Try to, increase the web distribution energy, and we try to reduce the web transmission. Also, in the same time, also we can reduce the web reflection from the floating breakwater. I think this, the several type of floating breakwater. So I think you have already know about this. The structure, the sipil structures. And then not the issue here. Regarding to the numerous floating breakwaters, unsatisfactory web attenuating effect water, especially in the long web. Moreover, the existing design of floating breakwater also dictates larger width dimension. So I think actually it's very logic. Once we build up the floating breakwaters with the higher large dimension, of course, it will more effective. But actually, in terms of the cost, also is proportionally increased. And we try to trade off regarding to this matter. Maybe I would like to show into the optimization of our water design in the next slide. So the solution here, we would like to, arrange the optimum space ponton. To reduce, especially the web transition coefficient, and try to increase web distribution energy, and in the same time, we try to reduce the reflection coefficient. Okay, actually, this, the KT value of the waters, from the spectral type. So you can see here, the value of the KT here is about 0.4 of the depth ratio, and then here is about ratio of the wavelength. So the KT here actually is still less than 0.5. So actually this is the latest one, the latest design. So this actually being constructed at China, and from that model actually we would like, we have extended, finding the more of the floating breakwater. Okay, so regarding to the, configuration here. So our twin ponton floating breakwater. First, we would like to optimize the width, also the trap, and also the porosity. Because later on, I would like to show you the high construction of our floating breakwaters. Actually, composing of the two pontons. And in the same time, also we extend the block up the weight by the face. Like, and then the purpose, the main objective, we try to minimize the KT and KR, and we try to maximize the value of the KD. Actually, this our design of the helicopters. So you can see here. So this the ponton, and the ponton has a spatial distance and connected with the connectors here. and below the ponton, we install the mesh cage or fish cage. And we also consider regarding to the of the fish cage here. So what we would like to do on these floating big waters, yeah, actually this is like there is a gap, yeah, from the existing floating big water. So we would like to actually arrange the distance between these two pontons, yeah, because these two pontons actually giving a significant effect to the, value of the KT. What we found actually in this research, yeah, we have a reduction about 8 to 12% of the web transmission coefficient reduction. Okay, that's let's out. And in the same time also, we have simulated, to optimize this distance and also to optimize, the value of the depth ratio. So using the genetic algorithm. So actually it's very basic. This tools if applied in the mechanical or electrical, but it's still rare applied to the coastal protection. So why we involved with the AI or artificial intelligence? Actually, it's very powerful to find the optimum one. Yeah, because it's very effective. Instead of we try one by one, and we claim that this the optimum one, and we never do the optimization. Actually, we cannot claim that the optimum one. But if we have done the optimization, then we can claim. Okay, and then the next slide. So actually, this the application of the algorithm on in ponton, in big waters. So this actually our objective: minimize the head, maximize the energy loss, and minimize the reflection. Yeah, because what happened in our area by constructing the fixed big water, actually NIPA, the erosion near the, so meaning that if the pep is like more friendly with the brick water instead of the fixed one. Okay, so actually the basic logic of the GA is about finding the the best genetic. So we employ here about 200 population in our case, and then we employ also about 20, meaning that in one time we can generate about 4,000 candidates. Which one is the optimum one? So basically, the application of the genetic algorithm is following the human characters. So means that we try to couple between the best genetic with the other genetic, and if this genetic birthing another genetic. So if the good genetics will survive and the bad genetics will die, something like that. So meaning that within a 4,000 candidates, this will create the optimum, the best genetic that representing of the optimum design of the floating big water, something like that. Okay, actually this, the procedure, how to conduct the optimization for our study. Yeah, actually this project supported by Ministry of Science and Technology Malaysia, for about 900,000 ringgit. So maybe equivalent to 3.15 million rupiah, or billion rupiah. So actually, our focus on the, this in the red box. So this just doing the optimization, and then continuing finding and so on. So this is looping. Yeah, if still not finding, the optimum one, so this will re-simulate again. So one point that the more interesting in our optimization actually is not pure theoretical, because sometimes the candidate of the optimum design getting from the MATLAB, what we have done, is not fully proven when we evaluate with in this case we evaluate with the CFD. So we have some maybe about if we have already the ranking, the candidate, the best candidate maybe from 4,000 candidates, we just list down maybe for about 10 candidates. So we try to do the ranking. So we examine something one by one. So from the 10, maybe proven is only 2, maybe proven is only 1, because using the MATLAB, then we evaluate using the CFD. Okay, actually this, I mean, the mathematical modeling, I mean, that's employed in the CFD. Yeah, so actually CFD is using the VOF, yeah, volume of the fluid, and then applying the, I mean, Navier equation model. And this actually the equation that we do the coding in the MATLAB, yeah, to find the optimum design of the inspiration ratio between one ponton to another ponton. So here the equation for the minimizing the KT, and here minimizing the KR and maximize the KT. So actually, this actually getting from several data that initially we conduct. From the data, we try to understand, I mean, the philosophy of several aspects that's giving the contribution to the changing of this value. So meaning that we cannot conduct optimization if we don't understand the physical meaning of our model. And I do believe that from ITD is expert on this matter. Yeah? Okay, so this the boundary limit that we conducted. So we try to minimize, I mean, the minimum value of the property is 2.0, and the maximum is 3.5. And that also is the some constraint that we employ in optimization. Okay, and then regarding to the depth ratio, how much we get the optimum get to the H over D. Yeah. So I'm considering the clearance, the fish cage. Then next, also we try to optimize getting to the fish net ratio, or maybe like porosity in civil engineering, because it's not solid, I mean, the but in the fall, in the height of the water maybe not partly reflected, but the water still absorbed, passing by the polluted water. Okay, and then this, I mean, the dimension of our polluted waters. And one more thing regarding to the so we add here the curtain. Yeah, curtain means just to I mean, block the web, overtopping web, something like that. So it's the additional I mean, element compared to the initial design of this polluted water. Okay, you can see here. So can you imagine? Yeah, I mean, artificial intelligence or machine learning. Currently, we call machine learning. So finding the optimum design between these two pontons. And actually, this is the practice study that we conduct. And yeah, as I mentioned before, so we also operate, I mean, the simulation of the optimization with the CFD. And here we are employing the, I mean, ProDD. So ProDD actually is a reputable software also, especially in the civil engineering, because it's also dedicated for the hydraulic, metals. Yeah. Yeah. So this is our setting, and then this, I mean, we got from the, I mean, the simulation, and yeah, we compare with the existing model test that I mean, published by G et al. 2015, and yeah, so far we're getting a fairly agreement with the experimental model test, our result. So from here, we are confident to continuing with the optimization later on. Okay, and then this, I mean, the value of the KT regarding to the values of the web length, also web period, and also web height here. And yeah, again, sometimes if we directly conduct the optimization, I mean, the modeling directly using the, I mean, commercial software or CFD, yeah, sometimes we cannot understand regarding to the basic mechanism. Yeah, because of that here, we also conducted, I mean, 2D analysis regarding to the, I mean, performance of the polluted waters with our own coding. So from this actually this using the metric, so we can see here, I mean, regarding to the I mean, color code here. So the amount of the wave energy is proportional with the increase of the wave period, indicated by the vector of the blue color. So meaning that more longer of the will be more longer of the wave energy. So this is, captured by our simulation. So actually, this is not CFD, but on this 2D, analysis. Okay, you can see here also regarding to the, web height. So you can see, how much the blue color happens not only in the surface, but also in the, nearby the seabed. So this indicating sometimes, scouring happen, or maybe accretion from some breakthrough here, it may, happen. Okay, and then, so before we actually try to conduct the irregular wave in our simulation, again, we try to, in the initial stage, we try to employ the regular wave condition first. So you can see here, the value of the, KT versus the depth ratio, and also KR versus the depth ratio, also KD versus the depth ratio. So meaning that you can see here the value of the KT going down when the increase of the depth ratio, and then similarly also the KR, but this will be opposite, effect with the value of the wave distance energy. Okay, so I think this in irregular wave, so we conduct here. And this actually, I should mention here that our optimization actually is not single optimization, but we involve a multiple optimization, multiple objective, because our objective is not one, but our objective here is we set become three. The first is reducing the KT, the second is increasing the KD, and the third actually reducing the KR. So actually it's a multiple objective. It's more complex compared to the single optimization problem. So from here, we try to employ several, various of the population. Is it in the population of our simulation effect to the result? So we can see here, the increase of the population will be more dense. Will be more solid. So of course, this indicating that our simulation is converged. Once converged, we will stop. Okay, and then you can see here that finally we got the result that from this optimization we got the variation ratio between one photon and the photon about 2.72. So the maximum value. Okay. Actually, this if we would like to plot, the value of the KT, KR, and KD in the 3D graph, so you can see here and getting the correlation that the increase KR, so means also reducing the KR with reducing the KT, and similarly increase the KD. Okay, similarly here, the value of the KR regarding to the depth ratio and also regarding to the porosity. So this the correlation between the wave coefficient with the physical model of the structure itself. Okay, so regarding to the porosity, we got the value of the porosity is 0.5567. It's likely like a tricky number, but really after that we try to evaluate with CFD and finally improve it. I would like to show you later on the visualization of the CFD itself. Regarding to the assessment of this optimization model. Okay, so actually this regarding to the CFD. So KT was significantly suppressed to less than 0.3. So our model actually is a bit significant reduction of the KT, because the current KT is still less than 0.5, but we got actually 0.3. So it means that it's more effective with the current existing model, because maybe it's due to it's not conducting yet the appreciation, but our KT actually getting less than 0.3. As I mentioned in the previous slide, the KT is still less than 0, but we got more less here. Okay, you can see here, the visualization of the optimum velocity water. So the yellow color actually is the velocity. So this is the existing one. When the wave passing by the prolific waters, so the velocity is still higher here. But when the wave passing by the optimum prolific water, we can reduce the yellow color here. So once the wave velocity reduced, so this proportionally with the reduction of the wave energy. Okay, and then regarding to the wave energy here, so this you can see the top one is the existing quantum prolific water, and this is the optimum one, and the blue and green actually is the less energy happen one passing by the prolific water. This indicating that the erosion actually can be reduced. The potential erosion can be reduced just by applying this prolific water. Okay, if you want to see regarding to the wave distribution energy, once the wave passing by the prolific water, you can see at various time. And this the animation that we have conducted, and we do this simulation for this case is about maybe 8 days. Yeah. So today we are running, maybe another 8 days we get the solution. Okay, we can see the video. Yeah, actually, PPFP. Yes. So actually, this the wave generator, and this is the prolific water, and we just simplify the slope here by the coastal dot. So when passing by, you can see here the suspended increasing, and the effect element characteristic will be oppositely. So actually, you can this still theoretical, but actually in actual it's also difficult to capture the sediment transfer, isn't it? And also the effect sediment. Yeah, but maybe by CFD we can more easier. But regarding to the validation, we did more verification for the next model test. Okay, so I think really the bedrock condition regarding to the optimum TPFP model. So here that the optimum TPFP model leads to further reduction in the rate of the gradient of the bedrock and substrate sediment compression by approximately 200 until 400%. So if we see the animation from the optimum design. Okay, and then the optimum design also leads to reduce the sediment transport for about 30% at the web length 1.2 seconds, 10%, 1.3, and 5%, 1.4. Meaning that in the long web, the efficiency of the prolific water is also getting reduced. So actually, this the scouring characteristic when the wave passing by the water. This is the existing one, the optimum one. So this is the scouring characteristic in front of the breakwater, and also the back side. So maybe from here we can see the obvious one. Regarding the existing, it's more red color here, and this actually reduce the red color. Also similarly happen here. The existing one is still red, and the optimum one getting yellow. So meaning that actually this prolific waters, very efficient. Take it to the wave energy, and also still also friendly because it's not structured, but it's like this soft structure, because we also try to reduce the reflection phenomenon in front of the breakwater, compared to the fixed one. Okay, actually this is the conclusion. So thank you very much, and thank you. Assalamualaikum warahmatullahi wabarakatuh.
Oke, terima kasih untuk presentasinya, Pak. Untuk sesi ini apakah ada yang mau bertanya? Satu.
Ya, kalau boleh jawab saya jawab, kalau tidak boleh jawab saya akan minta Dokter Intin untuk menjawabnya.
Iya, baik. Assalamualaikum warahmatullahi wabarakatuh. I'm so sorry my English so bad, so I can use bahasa.
Ya.
Jadi begini, sebelumnya presentasinya sangat menarik ya tentang penggunaan floating breakwater. Paling yang ingin saya tanyakan tidak masalah teknis sih, karena tadi berhubung analisis sudah lengkap banget ya. Nah, paling mungkin ada sedikit yang mungkin saya rasa terlewat atau mungkin saya tidak analisis sampai lengkap. Jadi apakah si floating breakwaternya itu sudah mencakup untuk kondisi pasang atau surut gitu. Nah, kemudian juga tentang bagaimana analisis benefit of cost ratio-nya. Memang kita tahu bahwa floating breakwater ini tuh memang murah gitu kan. Nah, cuman kan kita perlu juga sadari bahwa yang namanya sebuah struktur pasti perlu maintenance gitu kan ya, perbaikan tiap berkalanya. Nah, saya ingin tanya tentang maintenance-nya ini gitu, seberapa berbeda gitu dengan breakwater pada umumnya gitu. Takutnya kan murah di awal, ternyata maintenance-nya per bulan gitu kan ya, per ini gitu. Dan terakhir paling untuk masa layan dari si floating breakwater ini gitu, seberapa lama gitu masa layannya, masa pakainya gitu.
Lifetime-nya.
Ya, dan sedikit apakah udah dianalisis material pontonnya gitu? Mungkin udah. Ya, analisis materialnya. I'm so sorry. Thank you.
Terima kasih. Oke, pertanyaan pertama tentang pasang surut. Ya, memang kita belum ikuti pasang surutnya. Kita masih fokus kepada reguler dan irregular wave. Nah, tapi dari situ boleh diindikasikan ketika surut berapa, karena kita juga memang covering from the short wave up to the longer wave. Ya, dan also itu kita ada depth ratio. Nah, jadi mungkin indirectly already answered your question. Tapi specifically we are not mentioned in the slide. And then regarding to the nantinya mahal. Ya, floating breakwater yang kami guna pakai actually adopting from China. So the material actually concrete and reinforced by the composite. So actually when concrete and reinforced by composite, side is good, isn't it? Because keeping the buoyancy. Otherwise, it will be submerged. So, so actually made from concrete and marine is quite sufficient enough the strength. And actually the composite just to reinforce in the outer, something like that. Of course, regarding to the cost maintenance, it's not easy to corrode it. Maybe just only barnacle. Yeah, I mean, adhering to that structure. But currently, really, so many already products regarding to the anti-barnacle. Maybe we can add more. Okay. Regarding to the lifetime, yes, the concrete. Yeah, I mean, if you are from civil, you know better than me. Yeah, something like that. So I cannot say. Yeah, maybe it depends on the step that we are using. About 20 or maybe 50. Maybe to the maintenance is not about the material, but it's about the mooring actually, because it needs a mooring. Actually, it's also tall, yeah, because it's maybe will be fatigue happen, yeah. And also the installation of the mooring also need more proper. But this actually done already also, but maybe meet you again in another scenario. Okay, so I think is it already answered the question? Thank you.
Okay, so I finally have someone who wants to ask on my right side.
Bukan bertanya tapi jelaskan ke.
Nggak betul bertanya, Pak. Thank you so much, Pak Professor Fitri, for the presentation. Very actually interesting, especially in the part of I just discussed it with Yunita, the optimization of your problem. My question is, your model is only two direction, right? Two directional, right?
Yes.
The wave comes perpendicular to the beach. So in the beginning, you give an example of the structure which is perpendicular to the beach, so that the mechanism of the sedimentation would be different.
Yes.
So if the wave comes in the angle to the beach, then there will be the longshore current and
Longshore
longshore
current,
sedimentation. So it would be very interesting probably if we model with the 3D probably in the future.
Yes.
Is that possible?
Yes.
In my opinion, maybe. So
Yes.
okay.
Yeah.
All right. So with the optimization and maybe the modeling in the lab with your loading
Yes.
structure, and then we will model the sedimentation behind the breakwater.
Absolutely.
Is that possible?
Yes.
Thank you so much.
Thank you. Prof. Nitin, regarding to your question. So actually, we have also some planning regarding to the, changing the web direction. Yeah. Unfortunately, we have not conducted yet because, again, actually, this also simulation is very, lengthy, as I mentioned, maybe about more than 1 week for one simulation. But regarding to the optimization from the numerical simulation of using the GA, I think still possible. But sometimes once we got the result, we are still also questioning if we don't verify. So maybe this is your good suggestion, and this become my homework when I come to the MT later on. Thank you very much.
So thank you for the presentation, Dr. Fitri. I think this is the end of the session for Dr. Fitri because we have a limited time. We're running out of time. So maybe we can move on to the next speaker, but please, can you give applause first? Yeah. Okay. So the next speaker is Professor Ricky. He's actually a lecturer in ITB, specialized in offshore platform. So he's giving a presentation regarding his current project about the commissioning of the platform. So for Professor Ricky, time is yours.
Assalamualaikum warahmatullahi wabarakatuh. Selamat siang semuanya. Jadi saya pakai bahasa Indonesia saja ya. Kalau bahasa Inggris masalahnya saya sudah lama nontonnya bukan Hollywood tapi drama Korea, jadi agak susah. Ya, sebetulnya ini saya ditugaskan oleh Pak Eko dan yang lain-lain gitu ya. Untuk menjelaskan tentang decommissioning. Jadi kebetulan kita mempunyai project ya, dari IKT tentang decommissioning. Ke depan atau ke belakang? Oke. Ya. Jadi outline-nya adalah tentang introduction, ongoing, decommissioning. Mungkin saya agak cepat ya karena sudah panggilan alamnya ya. Jam 12 ini sudah kurang kreatif. Ya, introduction, jadi decommissioning apa sebetulnya agak panjang ya, tapi mungkin saya akan coba lebih pendek kan. Jadi life cycle dari suatu offshore structure ya, seperti biasa mungkin di dalam kelas ada mulai dari eksplorasi, appraisal, apakah feasible atau tidak, feasible di develop dan dibangun dan di production, dan setelah selesai kemudian adalah abandonment atau decommissioning ya. Nah ini terkait dengan beberapa hal harus dilakukan, jadi misalnya keekonomiannya sudah tidak bagus, juga dari segi safety dan environment, benar reputasi dan liability dari company, ya, dan juga secara hukum itu mengharuskan dilakukan abandonment atau decommissioning. Jadi di sini biasanya disebut abandonment and site restoration, ya, atau di dalam SKK migas biasanya disebutnya kegiatan pasca operasi. Ini memperlihatkan gambaran ya perbedaan antara decommissioning dengan construction. Jadi sebetulnya rule of thumb dari construction itu sebaiknya atau lebih banyak diwajibkan ya, pekerjaan itu dilakukan sebanyak mungkin di onshore ya, di darat itu supaya lebih efisien dan juga artinya lebih murah ya. Jadi semua dikerjakan di darat sampai satu jadi jaket misalnya, kemudian dibawa ke offshore untuk installation. Nah, tetapi untuk decommissioning kebalikannya, pekerjaannya akan lebih banyak di offshore karena ini pembongkarannya misalnya di laut, mulai dari topside, jaket dan sebagainya. Jadi di sini kebalikan prosesnya. Tapi dari segi biaya itu ya kalau di luar negeri yang saya dengar decommissioning biasanya malah lebih biayanya lebih mahal daripada waktu menginstalnya ya. Karena kita bekerja dengan struktur yang sudah lama ya, jadi sudah berkarat dan sebagainya. Ya, kadang-kadang kalau safety level atau safety standard dari company itu sangat tinggi, kadang-kadang yang sudah karatan itu harus di strengthening ya, diperkuat supaya tidak rusak dan sebagainya. Ya. Kalau dulu saya mikir malah rusak juga nggak apa-apa, orang mau dibuang kok ya. Tapi bongkarannya itu dulu tidak terpikirkan akan serumit seperti sekarang. Gitu. Jadi di sini disebutkan misalnya 95% itu memang tidak didesain. Nah dengan ini mungkin ke depannya kita akan kalau mendesain dari suatu platform harus mulai dipikirkan tentang decommissioningnya. Decommissioningnya kemudian juga mungkin dari segi lingkungan adalah material-material yang akan dipasang di sana jangan sampai yang limbah B3 misalnya karena akan mempersulit nanti decommissioning. Jadi itu satu teknologi yang akan harus dikembangkan. Ya, jadi di sini decommissioning akan lebih sulit ya daripada instalasinya sendiri. Oke, di Indonesia sendiri sudah banyak platform ya, jaket terutama fixed platform. Jadi di sini 321 atau 57% berumur lebih dari 20%. Karena dibangun sejak tahun 70-an, 80-an sudah dibangun. Di mana saya angkatannya 78, kalau pakai komputer segede ruangan ini ya. Jadi dulu saya nggak tahu juga ngitungnya pakai apa gitu. Tahun 70-an. Di sini banyak sekali yang sudah lama ya. Tapi kembali karena teknologi ya, waktu itu mungkin didesain untuk 10 tahun ya life cycle-nya. Tapi karena perkembangan teknologi, reservoir yang sudah tipis itu mungkin bisa dilakukan satu, misalnya water injection dan sebagainya. Dan kemudian juga walaupun sedikit ternyata masih visible karena namanya hydrocarbon ya, fosil ini ya akan tambah lama tambah sedikit dan akan mahal ya. Jadi ini gambarannya sebenarnya di Indonesia sangat banyak sekali ya yang harusnya di dekom. Oke, jadi decommissioning sendiri yang sedang banyak dilakukan, misalnya sini ada beberapa opsi, contohnya ini mungkin nanti mahasiswa yang lebih tahu dari saya ya. Jadi ada removal to shore ya ke laut, kemudian reuse ya untuk ada development, ada yang paling sekarang banyak dilakukan adalah reuse untuk rig to rig. Ya. Ada juga yang untuk rig to fish farm misalnya. Cuman memang aplikasinya di Indonesia masih kurang menarik. Ini adalah videonya, tapi saya angkat saja. Ya. Nah, ini adalah riset yang berlangsung di tahun 2022 ini. Ya. Sebetulnya ini adalah kelanjutan. Ya. Di tahun 2021, ini kerjasama dengan UTM, ya, Profesor Umar, ya. Umar Yakub, ya. Dan beberapa university ya dari Asia dan juga dari Eropa, dari Inggris. Nah, di sini dibiayai oleh Inggris ya. Jadi mana ya? Nggak ada lupa ya. Royal Academy for Engineering dan Lloyd Register Foundation. Jadi di sini lebih banyak kegiatannya adalah kesiapan dari yard. Yard ini adalah survei di yard di Indonesia dan di luar juga. Ya, karena ini adalah kerjasama beberapa university. Di Indonesia ada beberapa yard yang kita lihat kesiapannya seperti apa untuk menghadapi program-program decommissioning. Ya, di antaranya Maindo dan sebagainya. Baru ini saya lihat ada papernya yang sudah di-accept ya, untuk publication tentang yard ini. Nah kemudian di tahun 2022 ini karena ada kegiatan kedai reka, kita melanjutkan khusus untuk di Indonesia. Di Indonesia untuk jadi di proposalnya ada untuk struktur platform yang kecil. Untuk kemudian nanti kalau dilanjutkan ke struktur platform yang lebih besar. Hanya mungkin masalahnya adalah tentang pembiayaan. Jadi programnya sudah selesai, uangnya nggak turun-turun juga sekarang. Jadi beberapa ini yang dikerjakan. Oke, jadi ini sebetulnya saya sih hanya sebagai penggembira ya. The main people adalah yang muda-muda ya. Ini ada Dr. Eko ya, kemudian juga Farid yang masih honeymoon karena baru nikah hari Minggu kemarin. Ini ada dari lingkungan Pemadai Wahyu, Pak Mamin, Rahman Mamin, ada Jessica, Sari, ada Dega, dan Maulida. Jadi ini adalah sebetulnya mereka yang running program. Kalau saya sih katanya yang kita harapkan adalah yang muda-muda ini yang akan melanjutkan. Kalau saya kan dalam tahapan menuju pensiun. Nah ini activities ya, banyak juga mahasiswa yang sebetulnya mereka mengerjakan studi literatur, regulasi dan sebagainya mungkin ya. Jadi mungkin secara analisnya malah mereka lebih tahu dari saya gitu ya. Jadi ada desk study di sini dilakukan di kampus tentang studi literatur, juga visit ya ke Handil, ada juga yang ke Bintan sini, dan juga ada table sheet yang tadi Dr. Fitri bilang kalau di UMT ya punya fasilitas sendiri untuk table sheet ini. Ya. Jadi mungkin kalau nanti ada program lagi jangan ke Tangerang, ke Banten ya, cukup ke Malaysia saja. Jadi sini table sheet dan sebagainya. Ini adalah bagian dari pengalaman untuk mahasiswa. Jadi proyek kedaerahan ini sebetulnya adalah untuk melibatkan kegiatan mahasiswa untuk supaya mereka lebih tahu dengan kegiatan di industri. Dari hasil mahasiswa di sini diperlihatkan dari beberapa paper itu dari negara itu mereka melakukan aturan-aturan dan mengadopsi aturan yang kemudian kita temukan ada 3 aturan yang atau standar atau rekomendasi yang banyak digunakan di sini Basel Convention, UNCLOS dan IMO. Basel ini lebih banyak ke limbah ya. Jadi kembali seperti saya dapatkan misalnya waktu FGD ya, itu disebutkan kalau di ONWJ kenapa nggak langsung potong terus dibenamkan di situ saja. Ternyata nggak boleh oleh KLH, katanya ada chat yang B3 lah gitu ya. Ya, saya bilang ini mestinya dari dulu nggak boleh. Kan, ya. Jadi sekarang itu jadi harus dibawa ke Pulau Biawak kalau salah. Itu aturan dari KLH dan kembali menjadi mahal jadinya. Ya, jadi di Indonesia masih belum ada yang dikerjakan, tapi itu adalah biaya jutaan dolar untuk pembongkaran plafon. Tapi pembongkaran plafonnya harus oleh company dari Korea, termasuk kapalnya ya, dan sebagainya. Jadi mereka membeli pengalaman lah gitu ya. Korea sangat agresif dalam hal di commissioning. Jadi mereka memberikan uang government-nya dan dengan syarat yaitu kontraktor Korea yang melakukan. Close ini ya mungkin saya skip saja ya. IMO juga yang mungkin menjadi perhatian waktu saya presentasikan di kalangan oil and gas ya adalah tentang apakah platform tersebut harus dipotong sebetulnya atau sebagian. Karena kalau di aturan di standar IMO misalnya disebutkan kedalaman 70 meter, 75 meter itu harus dipotong seluruhnya ya. Bahkan sampai di 3 feet atau 1 meter di bawah mudline. Dan itu sebetulnya karena kita pernah juga menanyakan detail engineeringnya, itu cukup memberatkan karena mat di bawah mudline itu ada biasanya kalau jaket itu ada mat mat ya. Nah di atasnya itu ada matnya, jadi kalau diangkat cukup berat dan itu membutuhkan crane capacity yang lebih besar. Jadi di sini disebutkan misalnya entire removal is not technically feasible or would involve extreme cost. Nah itu boleh mungkin itu gambaran-gambaran dari Indonesia sendiri sudah mulai ya. Jadi walaupun platformnya sendiri sudah dibangun dari tahun 70-an bahkan tahun 77 di mana API standar mulai menerapkan revision period 100 tahun, Indonesia juga mengeluarkan peraturan yang sama di tahun 77 ya. Tapi tentang decommissioning sendiri ini mulai dari tahun 2008, 14, 21 dan seterusnya. Jadi memang agak terlambat ya, tapi sama seperti halnya di luar negeri juga begitu. Oke, ini masih tentang regulasi, ini dari hasil pekerjaan dari mahasiswa nih, kayaknya mahasiswa lebih pintar dari saya gitu, membaca ya semuanya. Oke, tentang metode, jadi platform removal ini ada beberapa hal yang mungkin karena ini lingkungan masih mahasiswa ya. Oke, kita biasanya bisa di remove one piece ya, yang menjadi removal dari top side itu sangat mudah ya. Potong, lifting dan diangkut kemana atau mungkin jadi recruit dan sebagainya. Tapi yang jadi masalah adalah jaketnya. Jaketnya ini secara harga ya besinya sudah karatan ya, dan sebagainya. Tapi untuk membongkar dan mengangkatnya itu malah jauh lebih mahal dari top side-nya. Itu yang jadi menarik ya. Jadi di sini biasanya ada studi-studinya ya. Pertama mungkin kalau top side-nya sih sudah pasti one piece ya. Biasanya ya, jarang sekali yang beberapa piece karena train capacity di dunia ini sudah sangat besar sekali ya. Dan platform di Indonesia masih sangat kecil lah dibandingkan platform yang di North Sea misalnya. Ya, kemudian jaketnya harus distudi, misalnya apakah dipotong keseluruhan atau dipotong sebagian di beberapa bagian. Ini pembongkaran dek seperti yang saya sampaikan, jadi itu sangat simpel ya, dia dipotong dan biasanya menggunakan rigging atau pad ice yang memang dulu digunakan waktu installation, waktu install kan di lifting ya. Nah, itu biasanya kegiatannya dilihat pad ice-nya, bahkan biasanya dilakukan NDT untuk memastikan bahwa pad ice-nya masih bagus. Dan dipotong di bagian ini ya, nanti ada studinya juga, dan diangkat ya, lifting. Jadi sangat simpel untuk top side-nya. Tentunya ada pertimbangan bahwa beberapa equipment di dalamnya itu mungkin diangkat duluan ya untuk mengurangi berat dari top side-nya waktu lifting. Ini studinya untuk top side. Nah, pembongkaran jaket biasanya di dalam desain dari platform atau kegiatan oil and gas ya, itu ada conceptual, fit, dan EPC ya, construction-nya. Nah, biasanya dilakukan konseptual dulu, ada beberapa alternatif yang harus distudi. Ya. Dalam konseptual selalu ada minimal 3 alternatif. Dan 3 itu dilakukan feasibility study-nya, artinya keekonomiannya mana yang paling visible. Dari segi technical, ekonomi, dan juga safety. Nah, di sini mungkin dilakukan studi misalnya dipotong 4 bagian, ya, U2, 3, 4. Ya. Nah ini tentunya ada banyak kegiatan underwater activities ya untuk pemotongan dan sebagainya. Nah tetapi di sini jadinya crane yang diperlukan akan lebih kecil. Itu di dalam conceptual study itu biasanya kita lakukan harganya berapa nih? Crane barge-nya itu ada di mana? Itu kan mempengaruhi biaya transportasi, dan, mobilisasi dan demobilisasi. Kemudian opsi yang lain misalnya yang angkat sekaligus. Nah, ini juga yang kami dapatkan waktu mengerjakan chevron misalnya untuk detail engineering-nya, yaitu kalau dipotong di bawah, ya, di situ ada mat, ya, sehingga di atasnya sudah ada lumpur-lumpur dan itu harus ikut terangkat dan itu cukup mahal. Cara pemotongan kalau kami lihat itu memang belum ada teknologi yang lebih baru ya. Lebih banyak pakai water jet cutting, itu lebih secara environment-nya juga lebih baik ya, dan juga bisa dilakukan dari dalam tubular. Itu terutama memang ini baik kalau memang harus dilakukan pemotongan di bawah mat-nya. di bawah lumpur ya, itu harusnya di dalam. Tapi memang akan kesulitan kalau ada obstacle. Ya. Jadi pernah kejadian juga kalau untuk motong di bawah mat itu jaritnya akhirnya digali. Atau digali dulu baru dipotong dari luar. Ya. Itu akan lumayan paham. Oke, itu untuk diamond wire cutting, ya, biasa untuk pemotongan. Ini lebih banyak pakai ROV, ya. Remote offshore vehicles operated vehicles ya, ROV. Oke. Nah, ini dari mahasiswa atau bukan ya? Lupa ya. Jadi dilakukan studi ya, dari berdasarkan decommissioning dari platform yang ada di California kalau tidak salah. Ya. Ini adalah percentage cost ya, costnya. Jadi kalau tadi kan saya sebutkan Korea memberikan uang 20 juta dolar ya, itu untuk meremove yang sudah dilakukan 2 platform. Saya nggak tahu apakah itu mengcover 2 platform atau ada platform lain, tapi saya belum dengar akan ada yang lain. Jadi saya anggap 20 juta dolar itu adalah untuk membongkar. Nah, untuk membangunnya itu harganya kira-kira sama. Ya, itu dengan artinya dengan equipment yang baru dan sebagainya. Nah, di sini diperlihatkan percentage dari setiap komponen waktu decommissioning, dan misalnya di sini dilihat platform removal-nya sendiri 31%, ada project management dan sebagainya. Dan satu yang menarik perhatian saat itu atau sekarang adalah tentang conductor removal. Ya, conductor removal ini bisa 8%, ya, 8% dari 20 juta dolar ya sama dengan satu rumah. Ya. Kira-kira sedikit lebih ya. Nah, ini satu hal yang secara mudah atau visible untuk dilakukan optimasi. Ya. Jadi conductor removal yang biasa dilakukan sebelum topside-nya dipotong, dia perlu pijakan. Jadi ini cutting, dan kemarin kalau dulu zaman waktu Chevron, dia harus di bawah 20 feet. Sebetulnya requirement-nya dari 10 feet ya. Tapi waktu itu diminta 20 feet dulu di cutting ya. Dengan asumsi kalau terjadi kesalahan dalam pemotongan lebih lengkap. Nah, biasanya di sini topside-nya tuh belum dibongkar ya, karena dia perlu pijakan waktu. Misalnya di sini ini masih cut proof. Ya. Jadi sebetulnya kalau dipotong sesuai dengan kapasitas part, biasanya itu 12 meter. Ya. Jadi diangkat dulu ya, dan diberikan pin ini ya, untuk menahan dan dipotong. Ya, dipotong 12 meter, simpan di parts ya. Kemudian pin ini yang nahan kan, kemudian diangkat lagi 12 meter dipotong. Ya. Jadi kalau kedalaman 40 supaya pas ya 48 meter itu berarti harus 4 kali motong. Ya, 4 kali motong, dan itu harga bars, crane bars dan sebagainya cukup mahal ya. Kalau dulu bisa 500.000 dolar per hari ya. Sekarang saya nggak tahu, tapi tetap mahal. Itu ya. Jadi mungkinlah anggaplah 200.000 dolar per hari ya. Kalau dalam rupiah, ya bisa pensiun langsung gitu ya. Kira-kira. Jadi 4 kali itu baru satu konduktor. Ya. Sedangkan di dalam satu platform itu bisa 8, bahkan ada yang kalau di West Madura Offshore WMO itu ada 20 konduktor. Jadi cukup mahal jadinya ya untuk mengangkat konduktor. Ini removal kalau dipotong dari bawah, jadi water jet cutting itu sebenarnya sangat kuat ya. Jadi misalnya di sini walaupun ada lapisan-lapisan semen ya, di antara ini itu bisa ikut terpotong. Nah, ini konduktor removal. Dan ini adalah mungkin opsi lain apa yang istilahnya untuk difungsikan untuk yang lain. Misalnya ini rig to fish farm. Ya. Cuman kembali ya di Indonesia rasanya belum. Yang menjadi masalah adalah kalau ini menjadi rig to fish farm, artinya platformnya sendiri belum dibongkar keseluruhan ya. Dan biasanya secara untuk aturan dari regulasi navigasi itu harus ada navigation aid, lampu dan sebagainya, lampu suar. Ya. Kalau tidak ada yang menjaga, biasanya itu cepat hilang. Ya. Lampunya hilang, platformnya nggak hilang. Jadi kurif bisa in situ dan ini ya in place, stopling, kemudian mungkin diangkut ke tempat lain. Ini saya kira. Untuk cost reduction, jadi yang menjadi masalah tadi kan, kalau jaket itu dia besinya sudah tua ya, kalau dia di lifting ya, secara safety-nya kalau mungkin waktu itu chevron ya, itu benar-benar harus tetap mengikuti aturan misalnya unity check yang terjadi lebih kecil dari the allowable ya. Jadi pernah ini ditarik, diletakkan di parts, ya, itu UC-nya 1,2 gitu. Saya bilang 1,2 itu masih ada safety factor, gitu. Jadi tidak sampai plastis. Tapi namanya chevron tetap harus di-strengthening. Sehingga biaya waktu kita melakukan detail engineering untuk chevron, untuk 7 platform itu biayanya $50 juta. Dan itu tidak jalan ya, karena diberikan ke Direktorat Jenderal Anggaran Kekayaan Negara, ya. Mereka bingung ini buang besi bekas ke $50 juta ya. Kalau uangnya nggak usah dikeluarkan dari negara mungkin tidak masalah. Yang jadi masalah adalah waktu itu Chevron minta itu sebagai cost recovery yang dihasilkan, sehingga tidak jadi. Nah, untuk mengurangi biaya lifting dan sebagainya, di sini kita mengembangkan, mencoba dengan metode floating. Ya. Jadi di-cut, bahkan mungkin konduktornya sendiri tidak harus diangkat satu-satu ya. Mungkin tidak hanya perlu karena konduktor itu biasanya kan tidak di-fixkan ke platform ya, ke jaket ya. Ya, jadi sendiri. Mungkin di atasnya akan di-fixkan dengan welding dan sebagainya. Tapi dengan disatukan dengan jaket ini, dan ini bisa diangkat sebagai satu kesatuan dengan konduktornya. Ya, kemudian nah kita usulkan itu dengan floater. Ya, floater jadi suatu buoyancy, mungkin bukan buoyancy tank ya. Kalau dalam installation untuk upending dan juga ini biasanya pakai buoyancy tank ya. Tapi yang ini kita usulkan bukan berupa buoyancy tank, karena buoyancy tank kan dari baja ya. Dan harus diikatkan ke platformnya. Jadi ini mungkin semacam seperti balon dan sebagainya. Ya, untuk ada yang bertanya, barangnya ada, saya bilang kalau industrinya menerima, proyeknya ada, pasti akan ada yang buat. Semacam itu. Jadi pedagang itu biasanya cepat sekali ya, menangkap pasar. Jadi ini pakai floater, jadi kalau waktu instalasi adalah upending ya, ya flooded, control flooding, kalau ini control floating. Ya, di sini, nah kemudian ready to sail away. Jadi kalau pipeline dulu ada namanya rentis method ya. Jadi pipeline itu cukup mahal waktu installationnya. Jadi pakai barge, S-lay dan sebagainya. Nah, rentis method itu dia bangun dulu pipeline-nya di sungai ya. Mungkin sampai 2-3, kalau nggak salah sampai 3 km. Jadi itu dipakai floating ya, pakai drum. Nah, setelah jadi diangkat ke offshore, ke lokasi, kemudian ditenggelamkan. Dan itu akan mengurangi cukup besar biaya untuk installation-nya. Nah, ini sama aja seperti itu ya kira-kira. Jadi di floating kemudian diangkat. Tentunya akan ada perhitungan-perhitungan yang harus dilakukan untuk membuktikan bahwa ini feasible ya, dari segi safety dan sebagainya. Oke, kemudian dari studi literatur juga, saya lupa ini dari mahasiswa atau bukan. Tapi metode floating ini sudah pernah dilakukan di Norway. Jadi mereka, ya, seperti yang saya sampaikan, jadi selalu ada vendor atau manufacturer yang membuat floaternya ini. Jadi dia di floating gini, ya, tapi dia berdiri posisinya. Sudah pernah dilakukan, berdiri, kemudian di towing. Nah, dalam hal ini di towingnya ke darat waktu itu. Jadi ini mungkin di tahunnya saya nggak lihat ya. Ya ini tentunya ada analisa untuk stability dan sebagainya. Ini menarik ya. Jadi saya ingat tadi Dr. Fikri dari Departemen Naval Architecture ya Pak ya. Naval ya, kapalan gitu. Jadi dulu saya disuruh belajarnya kapal sebetulnya. Kapal, nggak tahu kenapa saya belajar kapal. Tapi sampai sini pernah ada yang ingin juga dibuat di Indonesia ya jurusan perkapalan, tapi saya bilang industrinya tidak mendukung. Jadi karena kita kalah dengan Cina terutama. Ini naval architecture ya, jadi kestabilan dan sebagainya. Nah ini contoh mungkin buoyancy tank yang bisa digunakan, tapi seperti yang saya sampaikan, kalau ini metodenya diterima, mungkin nanti ada prototipe-nya, saya nggak tahu ya, bahwa ada simulasi fisik gitu, sebelum real ke platform yang kecil, bisa saja dilakukan. Sementara ya, harus
lagi. Nah,